That's awesome, man. Good for you. That was pretty cool, I'm sure, to take off behind that, what, B29, I think it was, maybe? B17?
It was 26, the consolidated. We came back right as the 29 was leaving. We landed, and then he back taxied. And so we got to see them both.
That's awesome. That's super cool.
I pulled the Skew-T from today, so I could have shown people what a smooth day looks like. Dang it.
Let's see. So I'm trying to get everything lined up here on Facebook. For some reason, it's not wanting to go. Yeah, it's good to see everybody again tonight. Martin, hey, how are you, man?
I'm great. Thanks. How are you doing?
Doing great. Doing great. Thank you.
Martin has that calming voice.
Yeah, that common Midwestern accent, right?
Yeah, Midwestern.
There you go.
Let's hear your best Midwestern, Martin.
You just heard it. Let's see. So we've got John. John, how are you, man?
Doing well.
Good.
Doing well. Nice to finally make it to one of these.
Yeah. Thanks for joining. I guess the last time I saw you was on the one for Aero Elite, I believe.
Yeah, that would be it. Yep.
With tail draggers, right? Yeah, that's what it was.
Yeah, Steve Hertz gave an outstanding presentation.
Yeah, he did great. That was cool. That was really cool. And let's see, who else we've got? Bruce, how are you? Maybe.
Bruce is good.
Bruce is good. I'm trying to get us going live over here on Facebook, and I'm having an issue with the connection for some reason. But anyways, did anybody go flying today that's on the call right now, or any good stories that you want to share with us while we're kind of getting settled in? I know there's something. Jeez.
And this weekend, my girlfriend and I are going to try to knock out 16 airplanes for the ambassador program.
16?
Yeah, we've got an ambitious plan.
That's awesome.
And visit some friends down in Hickory, North Carolina. So looking forward to that.
That's super cool. I hope to see some pictures along the way.
Yeah, we'll do. She's been a trooper about all this.
Yeah, that's cool. It's always easier whenever you have a trooper with you that is cool with that, as we all know. That can be a challenge, but.
Just make sure when you get the jacket, you get it in her size and give it to her.
So we've got we're gonna get 2.
Nice.
She has her own book.
I guess that makes sense.
Yeah, we figured that out after I knocked out the first 5.
That's super cool. Sorry, I'm a little preoccupied here, but trying to get this going. I'd like to get everybody that's on Facebook that doesn't normally join Zoom. I mean, it's funny to kind of see. There's always like this. It's like a similar crowd on either side. So I like to make sure we get on Facebook, but I'm not sure what's going on here.
Hey, Gabe.
Yeah. Hey, Johnny. How are you?
All right. I joined through Facebook link.
So I was referring to actually the Facebook live feed. So
Okay.
I normally put up. You're not referring to that, right? You're referring to the link.
No,
Okay.
just the link from Facebook for the event.
Okay. Yeah, I don't know what's going on, but that's all right. We'll figure it out. And just so you know, Rich was kind enough to let us record this, so we're recording this, and I'll put this on the website and also on Facebook if I can't get it on Facebook Live. But we'll go from there. So, but anyways, let's see. So we've got Mike Schwartz is online too tonight. Hey, Mike.
Good evening, Gabe and everybody. How are y'all doing this fine evening?
Good.
Great. And let's see, Vic Dad is online too. Got a good group tonight. I like this.
We knew we had so many weather geeks.
Rick Data is snarfing down some dinner. Hence,
Weather
that god awful
awesome
photograph.
because you can be wrong 50% of the time and never worry about getting fired.
Putting some fuel in the tank, man.
I haven't made it to dinner yet, but that'll be right after this, I hope.
You mean like ever?
No, I'm making the dinner. I gotta eat. I eat.
Yeah. I don't know about you, Gabe. I think you work all the time.
No. You gotta have time for fun, right? I gotta make that happen. Zach, what's up, brother? How are you, man? I'm surprised you're not building, working on your plane tonight, as always, in the garage.
The night is young.
The night.
Yeah.
How's that coming along, man?
It's coming along. I mean, I'm still doing tedious wing stuff, and I keep looking at the pile of fuselage parts, and I want to get started on it real bad. So yeah, a couple more weeks on the wings, and then I'll be ready to move on.
That's cool.
Is it true that if Alfred Hitchcock did a movie about it, it would be very riveting?
Ha.
Yep. Very riveting tale.
Well played. Well played.
I think he's setting the bar for the kind of comedy we're gonna have tonight.
Yeah. Give me just another minute or two, and then we'll kick it off here. I'm still trying to figure this out, but I don't know what's going on. Mike Lerner, how are you?
Good, Gabe. How are you?
Great. Amazon already still? Thank you. You too. Amazon comes at this time? How is that possible? I didn't know that.
You.
All right, I'm gonna try this one more time, and then if this doesn't go, we're gonna go ahead and get going here.
While you're doing that,
Yeah.
just a reminder, next Thursday at 7 is IMC Club, followed by VMC Club at 8 o'clock. Both get wings credits.
That's cool. Thanks for doing that, Mike. Hey, it was nice to see you the other day too, Mike, at Manassas. I'm sorry we couldn't hang out a little more, but we got 3 hours worth of video that day. So sorry we were a little preoccupied.
3 hours of video for 5 minutes of YouTube video.
Well, it's looking like about a 12-minute YouTube video right now. So we'll see. But
Hey, what you posted was awesome.
what's that?
I said what you posted was awesome.
Oh, thank you. Thank you. Yeah, there was a lot of good stuff going on there. We were lucky to be on the other side of the field, and it was pretty sweet. So, but well, anyways, I guess I can't get this going over here. We'll have the Facebook. We'll put this on Facebook via the recording we're doing now. But thanks again for everybody for joining tonight. I know I'm looking forward to this one. Something that I know I need to learn about, and I feel like a lot of other pilots that I've talked with say, this is something that it would be kind of nice to know further about for a variety of reasons. But Rich, it's been amazing to be able to meet you along the way and have you in the group and have you kind enough to say, hey, I'll put this together and let's talk about this. So really enjoying having you and working with you up to this point to put this together. So thank you. So Rich is based out of Culpeper, down in Culpeper, and he owns an A36 Bonanza. That's what he's flying these days. And you probably see a lot of his posts on Facebook recently. But I want to welcome Rich. Welcome to everybody who is here, who's a part of the club, who's not. There are a few new faces on here, so thanks for joining. But Rich, I want to turn it over to you. Just so everybody knows, we're going to try to make this as interactive as possible. As far as if you have questions along the way, I think Rich is totally cool to kind of roll with those questions. In addition to, we'll probably try to wrap up around 8:30, 8:40-ish, and go from there. So with that said, Rich, it's all yours, man. Thank you.
Yeah, thanks a lot for the great intro, and I'm definitely glad to be part of the club here. Can we just call it the club from now on?
Yes.
And so I've actually been meaning to put something together on SkewTLogPs for a while now. I took a course about 3 years ago through pilot workshops, and some of you may be familiar with Scott Denstead. He is a renowned weather expert, particularly in the aviation area. And so he was working with pilot workshops and offering up this training. I honestly don't even recall what got me into it. I think I might have heard about them and thought, you know, I'm flying an IMC a lot. I know I'm trying to avoid ice, and you know, I heard that this was a good way to do that. At least get an idea of what the atmosphere looks like, what the conditions are. And so anyway, I took the course and I was really blown away. His course is much more in depth than what we're going to go over. It was definitely more on the weather professional focus side of things. If anybody here has already taken it, maybe Martin, perhaps Martin has taken it, probably would tend to agree that it was very technical.
I agree.
Side. But it was fantastic, and I got a lot of kind of pulled out of it what I found the most valuable to me as a pilot, and I've been talking to other pilots about it. You know, even professional pilots, a lot of them are unaware or don't use it. But when I start talking about it, they tend to be pretty keenly interested. So anyway, that's kind of the intro to this whole thing. I do want to let you know that once we're done with this, you're not going to be an expert in this. I'm not an expert in it, and I use it regularly. Really what it is you're going to need to practice. And it does take some practice to kind of look at these plots and analysis and really understand what's going on. But it's well worth it, especially if you're the kind of person like me who flies in weather quite a bit. I find it extremely useful, and it keeps me out of trouble. It also helps me predict whether or not I'm going to have a new passenger with me, even on a sunny day. Is it going to be super bumpy? Are they going to puke in my airplane, which I don't want to happen? So it gives me a lot of data that I can use to predict things. It also allows me to do very good planning as I make trips. Now, the plot itself isn't really good. Just all by itself isn't good for a wide area, and I'll kind of go into the detail on that. But I can create multiple plots with an iPhone app I'll introduce you guys to that I highly recommend you get. And then I can plot every 40 miles on my trip, and I can watch the atmosphere change at the predicted times that are going to be crossing that area. And then I'll get a really good idea of what I can expect when I get somewhere. And on one of my last slides, since I couldn't figure out how to show you guys live on my phone how I use the app, I recorded it on my iPhone, kind of how I did a basic planning. And then I'll play that, and you guys, and I'll talk through it as we go through it, and you'll kind of see what I do when I do my flight planning. So with that being said, normally I'd run around the room and high five everybody, but we're not able to do that. All right, let's see here. I need to share. All right, everybody seeing this?
Looks good to me.
Excellent.
Yeah, that's good.
So if I talk through this whole thing and nobody talks to me or asks me questions, I'm gonna lose my voice, and it'll just be disappointing for me. I like to talk to people, so work with me on this. So SkewTLogP basics, and like I said, it is kind of the basics of it. This is gonna be a short course in it, but I think it's gonna be very useful to pretty much every pilot. I created this in a way that kind of takes out all the information I thought was important and kind of puts it into one presentation. I say that this presentation is prepared by me because I didn't make any of this up. This is just information that's out on Google, or universities offer data and courses. And so I pulled from various sources, including Scott Denstedt's articles that he's written. If you just Google him and go on YouTube, you find tons of information out there that's all free to use. So I did get a nice little intro there, but basically I'm not a crazily experienced pilot here. I mean, I'm 1,200, almost 1,300 hours. One thing is I immediately got my instrument rating when I got my private, and I did part 141 as a matter of fact, because I didn't have any other cross-country hours. Knowing that my goal in flying was to travel. And I have a little sampling here of kind of where I've traveled. I've been, down to Key West, across the country. I forgot to add Denver on here. I recently went out to Denver, up to Canada, So there's a large amount of territory and different types of weather that we can experience flying in these areas. And I did leverage Skew-Ts, you know, pretty much on all these trips. So anything that where I thought I might encounter any kind of weather. So I do fly a lot in IMC. And that's what happens when you want to travel somewhere. Or I used to, before COVID, travel quite a bit for work, which was really nice as well. So that's my panel over there. All right, can you guys all see this big giant arrow that I have here? Awesome. Well, what are we going to be even covering in this thing? I've already talked a lot, and we're only in like the third slide. But you know, the why and the what of SkewTLogPs, I'll explain to you why they're even called that here in a bit. But why is it even important to us as pilots? The type of data that is the source of the information that's plotted on this chart. So essentially, you have three main components to what SkewTLogPs are all about. You have the chart itself, which if you put nothing on it, is just empty, and it has lines and things, and I'll reference lines, I'll show you. Then we have the plot itself, which is the atmospheric data. And then we have the analysis that's run. So we'll go over that, and we'll go over some of it quite in depth, especially when we get into like convective activity and thunderstorms. But one of the really important things to do is kind of, now when I look at Skew-T plots, most of the time able to determine what to expect simply by looking at I see a signature pattern, what these look like, what the plots look like, and I'll immediately know, oh, it's going to be turbulent up to 5,000 feet, or that kind of thing. So we'll go through kind of the main signatures that you will see whenever something is plotted, and you'll be able to kind of immediately determine what's going on. So I'll have the signatures, which themselves are examples, but I'm going to go into other examples where I've pulled off of my phone some of the plots, and then I also, next to that, so I pulled a plot of just some random airport somewhere, SFO or whatever, and then I pulled up the TAF, or I pulled up the current weather to show you how that correlated. So this is Skew-Ts are not a exact depiction of what's happening right now, or it is a forecast, even if you pull up, for right now, the latest run, it's still a forecast. So even though we see these patterns on here, it's not a guarantee that something's going to happen, right? We may see patterns that are conducive to microburst, but that doesn't mean it's going to happen. Weather is complicated, complex. So, and then I'll show you that short video, kind of how I use it, and then further reading, which essentially is the sources that I use. And there are free full courses you can take if you're so inclined. I know Martin's going to do it. All right. So why do we even use these? By the way, this picture on the right here is from an app I use on my phone, SkewTLog Pro. The nice thing about it is kind of like a simplified version of what you get off of NOAA from the RUC soundings page. It has everything that you really would want here. Temperature, dew point, you have the analysis line, or basically the parcel line. And then you have your wind on the right and the intensity of that wind. So it gives me kind of everything I want without being overly complicated. And that's what I use in my examples when I go through this. But really, the why is it allows us to have more comprehensive flight planning. Simply put, it's just more information in one single place. And it's very hard to find this amount of data, an atmospheric analysis like this on any other product. You can gather this type of information by looking through other products. So one of my favorite sites is Aviation Weather. It has a tremendous amount of information, and I still leverage it, especially if I'm in icing, at icing time of year. It gives us an overall better understanding of the weather, the atmosphere itself, what causes weather. I mean, we all kind of know that the sun heating the earth really, and effectively cooling when the sun goes away, is what causes weather, the thermal activity. but it gives us a better understanding of how all those kind of pieces work together. And lastly, while there's safety, so having this information provides you as a pilot the ability to provide safer flights. And if you're carrying passengers, I'm pretty sure they'd appreciate that. And probably the most important is that you can impress your friends and family. If you show this to your friends and family, they won't know what you're talking about, but they're going to think you're a genius.
Hey, Rich, real quick, 1 second. Hey, do you guys hear kind of like a buzzing sound in the back, or is that just me? I wasn't sure.
It's not just you.
Okay.
I hear it too.
On my side, or maybe I'm the cause. I don't know. Here, let me see if I can.
Yeah, the audio quality is not great.
Yeah, I don't know.
Not here. You're loud and clear for me.
Okay, so it's not me. All right. Maybe it's Zoom.
He sounds like a Cylon from Battlestar Galactica.
It's pretty clear for me as well.
Yeah, sorry, I didn't mean to interrupt you. I just wanted to double check in case there was anything there. So go ahead.
All right, no worries. Any questions up to this point? I mean, I've done a lot of talking already. All right, any doubts as to usefulness of this so far? I'm guessing no. So what is a SkewTLogP anyway? It is one of several, there's like, I think 4 or 5 common thermodynamic diagrams that are used in weather analysis and forecasting by professionals. And this one just happens to have a tremendous amount of data that we can leverage. So we're going to go into detail on it. If you want to go to the real source of the information, you can go to NOAA's site, rocksoundings.noaa.gov. And a couple of the screen captures I have are actually from there. So that's going to give you, the most detailed data that NOAA has. They have supercomputers out there crunching data and populating this for us. So it allows us, based upon the signatures and data that we have available to us, it allows us to determine ceilings, maybe multiple levels of clouds. So for me, if I'm flying instrument weather, it is kind of nice to know, especially in the winter, if there are openings, if there are multiple layers of clouds, like maybe the cloud above me is only 3,000 feet thick, but it's not in the freezing level, I can get above it and then it opens up and maybe there's a layer above that or something like that. It gives me a really good idea of where I can be flying to improve safety, make sure that I don't encounter things I wouldn't like to. The other thing is determining tops. So ceilings are pretty easy. I mean, you just look at, the weather at any airport, you're gonna figure out what the ceilings are very easily, but finding tops and layers is difficult with the products that we generally use. We can determine icing potential. Icing is kind of one of those weird, elusive things. It takes a lot of all the right things to happen at the right time for icing to occur. Tends to be very thin in the atmosphere, meaning you won't see icing generally for 2,000 or 3,000 feet. Typically, it's in a small band. And there's a lot of reasons for that. Maybe somebody else can do a nice presentation on icing. Be able to identify wind shear, which for us in particular, the higher upper level wind shear stuff really isn't that big of a deal. Unless it's really powerful, we could expect, some major turbulence there. But if it's low level wind shear, I think we all care about that if we're coming into an airport to land somewhere. Determine rain, how heavy the rain could be, and then turbulence is a good one too. So these plots are really designed, if you look at the individual plot itself, it's designed to analyze a single point. And I'll talk about where those points are, but if you're looking for big picture stuff, generally I'd be looking at prog charts and other weather products out there that are designed for folks in aviation. And then you combine it. This is kind of another tool in your toolbox while you're doing flight planning. So there are 3 basic things that are plotted on this chart. Temperature, dew point, and wind. And from those 3 things, we can determine a tremendous amount of information about the atmosphere and the conditions. There are essentially 2 main data sources that we use. So there are radiosondes, which are balloons that are launched into the atmosphere, and they're by default, they're launched twice a day, but they can be launched more if we're trying to gather more data. And then weather prediction models. On top of that, we also have a lot of other, so as part of the weather prediction models and computed things, we have lots of other sources, and next slide kind of talks about that as well. Any questions so far about what it is, the usefulness of it? I'm gonna have to go to like a 1-question quota if I don't get any feedback before I advance. All right, so let's talk about the data. So this screenshot down at the bottom is actually from the Rux Sounding site, Rux Soundings at NOAA.gov. And you see that the initial data sources, there are several different choices. The ones that we'll almost always use, the number one that we'll use is OP40. And that's continental United States and 40-kilometer grid plotted hourly. There are also other sources like global, so that's GFS. If you're going outside of continental US, I don't think there's anybody here that would, need to use that. We have the radio sonde observations, which is the RAOBS. We also can choose aircraft sources. Now, what's interesting here, if we look at the radio sonde itself, it's launched twice a day. Like I said, 23Z, 11Z can be launched anytime to gather more data. But the interesting thing is, let's say there's a few puffy clouds, and this goes up through the atmosphere and goes right through the middle of a puffy cloud. So the radio sonde is going to detect that the temperature and dew point are the same, which is inside the cloud. But it may not be representational of the actual overall atmospheric conditions. So if you were to look at an actual plot from a radio sonde, it would be very jagged. The temperatures and dew points move around quite a bit, and it's just difficult to read. It doesn't make it very useful. So most of the time you wouldn't actually use that. But the radio sonde data itself is combined with ship weather, satellite data, all kinds of information that are run on supercomputers and numbers crunched to produce the analysis lines that we'll see in most of the plots that we get, in particular for the OP40. Any questions on the data sources? I'm sure most people are starting to fall asleep on this about right now. All right, but I do want to hit on it's important to know where the data comes from when you're looking at the data, right? You don't want to really look at something blindly. But really, there are two main things that we're talking about here from the analysis and forecast. The models aren't really taking radio sonde information and just interpolating the data. It actually is doing number crunching in a sophisticated way to produce reliable information. And it's historical data is leveraged, all kinds of information. On the right there, you can see the early models that were used were the rapid update cycle. And on the right is kind of an example of some of the sources of information that were collected and run by the computers to give us these forecasts. It's kind of interesting, like GOES as a satellite. Matter of fact, NOAA, in my business, what I do, NOAA is one of my customers. Kind of cool. This rapid update cycle was not very, it didn't have a lot of detail to it. So it was replaced, I can't remember exactly what year it was replaced, but it was a while ago, with the rapid refresh, or RAP. And it takes in more data sources, and it is much higher resolution. It's actually, so the OP40 I talked about being plotted at 40-kilometer points. So if you were to take a grid and build out a grid at 40 kilometers squares, it's actually all those grid points that are where the runs are at. But RAP is run at 13 kilometers filled out to 40 kilometers, which gives us higher resolution over all of the pictures that we would see, especially when they're plotted as predictive graphics, if you were to say look down over the US. All right, super boring stuff, I know. I actually like it though. But we do need to understand some of the, we need to understand the definitions of the words that I'm going to be using that are describing the lines on the charts. Hopefully that makes sense. So I'm going to be talking about isobars, these are lines indicating the same pressure. The next two are really important, the dry adiabatic lapse rate. You guys are probably, well, some of that stuff may be coming back from your primary training and instrument training, but the dry adiabatic lapse rate, the standard change is 3 degrees Celsius per 1,000 feet of altitude. Then we have the moist or saturated adiabatic lapse rate. That is 2 degrees Celsius per 1,000. Can anybody tell me why there's a difference there in the temperature change per 1,000?
The water holds more heat.
Yep, it simply takes longer for it to change temperature. Yep, exactly. Then we have isotherms. So these are lines indicating same temperature. And then we have something which is a bit confusing, but is really important later on in talking about thunderstorms and convective activity and potentials. But saturation mixing ratio. So this is the ratio of water vapor to air at a given pressure to be considered saturated. And we leverage this saturation mixing ratio when we do some of our analysis. All right. So here we have these definitions on the left that I was talking about and the corresponding lines. So the name SkewTLogP comes from, if we look at the temperature line, so the isotherms, let's see, I'm going to use this big. Here's the zero freezing. You see the solid line running to the upper right? They're running at a 45-degree angle, all of the isotherms. You see those? So it's skewed temperature, right, to the right. The reason why it's done like that is that a standard, if you were to plot a stable atmosphere, essentially you would have a straight line going up once, and I'll show you what the plot looks like, of temperature change. And then log P is logarithmic isobars. So here we have the isobars. On most plots on the right-hand side, you'll see the corresponding altitudes as well. On this particular example, we don't have that. So what we mean by logarithmic is, if you see here, we have 200, 250, 300, 350, 400. You notice how they're getting closer and closer and closer? Anybody know why that is? Why would pressures be getting closer and closer, lines of equal pressure? Think of the atmosphere, the weight of the
atmosphere is getting denser and denser.
Density of the atmosphere.
Right.
Yes,
So the more air you have, the heavier it gets. It's kind of like scuba diving, right? You go deeper, and then the pressure grows and grows and grows because you have the weight of the water on itself. So that's where the name comes from. All right, so we're looking at, here's A, we'll start with this, the isobars, lines of pressure, and then on the right, again, altitude. We have B, which is the dry adiabatic lapse rate, and we notice that it's changing at a higher rate than the moist adiabatic lapse rate. And the moist ones are kind of hard to see, but you see the dotted dashed lines here? They typically have that pattern. They come up and then they make like an S. The dry ones typically have this same shape too when you look at them. All right, then we have the isotherms. In this case, I just plotted this one here, but in the future plots, I always identify freezing isotherm. That's a really important one you want to pick out because that's going to determine if there's moisture in freezing conditions, right? And then E is the saturation mixing ratio. And that is this dashed line that goes off roughly almost at a 45. And they're all kind of, you can see them all here. Another one, another one, another one, another one, another one. And we use those in plotting some of the convective potentials. So it's important that everybody understand all of these lines. I'm going to keep talking about them as we go through, but let me know if you have questions. All right, so that was the diagram, and now we have the plot itself. On here, I've identified, again, one of the important factors, which is the 0 degree isotherm. So if we look, here is on the right, here's the temperature. On the left is the dew point. Typically they're red and blue, but so temperature is dropping. It's actually staying the same as it goes up with altitude. And then it comes to this point. This point, again, on the right-hand side, there's usually altitudes. That is the point or altitude at which freezing occurs. Okay, if we have moisture up in this area, and it's between 0 and 15 degrees, negative 15, we have a potential for ice. So that's something to consider. Again, the temperatures are warmer to the right, cooler to the left. On the right, we have our wind profiles. These are drawn various ways, but essentially it's just like this. I put this compass rose here so we can, this is a wind from the west, right? Down here, it's from the south. So we have a change in direction as we go up. This is pretty normal to see something like this. There's no drastic changes. So nothing to worry about on that type of thing. All right, then the third piece is the analysis. And so this is what we call the lifted parcel line. Later in the presentation, I'll show you how we actually can plot that ourselves. Luckily, you know, if you go to NOAA and you highlight the temperature at the surface and click on it, it'll draw this out for you automatically. But it's interesting and important to understand how it's drawn out. In this case, this whole section, this is convective inhibition, or not inhibition. Yes, it is inhibition. Just sounds weird for me to say it. Anyway, up here is we have positive area. So down here, air does not want to rise. Up here, it does want to rise. And if you see this shape that it creates, in this case, if this were a real profile, there would be a good chance of thunderstorms on this day, right? If you can get the air mass above here. So in our area, we have mountains that actually pushes air. If you notice going over the mountains here in the DC area, the air rises up as it normally would, and then pushes the air mechanically up into the point of free convection. And then that causes storms. All right, so one of the main reasons is for the use is to find clouds. I mean, typically we are interested in these type of clouds down here. I don't think there's many of us that are, even though at least some of us fly Cirrus, Gabe, you're probably not up here in them. But we're worried about these or concerned. If there are folks on the call that haven't flown through just normal cumulus, it's uncomfortable, right? They're bumpy. I tend to try and keep my family out of them, even though they look pretty and puffy. A lot of times there's turbulence, and sometimes it can be difficult depending upon how big they are to control the aircraft. Stratus, stratocumulus, nimbostratus, these are all pretty benign, but we know this big bad boy on the right is definitely one we want to avoid. Luckily today, you know, we have the ability to see embedded thunderstorms. You know, 20 years ago, life was a little bit different for the years before flight. All right, so I want to talk a little bit about stability indicators as far as how the temperature changes with altitude. So if we look on the leftmost, we have essentially a stable profile for temperature. Again, the line of same temperature, or the isotherm, is running to the right at 40. And this shows a stable air. So it changes at a standard temperature, essentially, as it rises. This is unstable. So I flew yesterday, and if you looked at the Skew-T spot from yesterday, you can see a line much like this all the way up until about 4,000 to 5,000 feet. And what this means is that down here, lower than that, typically you're going to have some turbulence, and it was. You know, at some points it was a little bit uncomfortable. Then we have the next one, which is an inversion. this is typically stable. In inversion, air is usually very comfortable to fly in. There's not a lot of air movement, which means that the entire air mass itself is staying in place, and it's just much nicer to fly through. Then we have, you know, an inversion that follows the isothermic line. They typically just call it an isothermic profile. Following, so it stays the same temperature as you rise up in altitude. Clear as mud.
Hey, Rich, maybe I look at it the wrong way, but shouldn't the inversion line be steeper? I mean, if I follow that line, it still gets colder with altitude, whereas in inversion, it's supposed to get warmer with altitude.
So even a slight to the right is still considered an inversion. And I'll show you like a fog layer later, which is like a foldover. Now, a lot of times you'll see, oops, I can't really, but you're right. So there's, even if it's less than isothermic, it's still considered an inversion. So almost straight up and down air is classified. This is not my data. This is all data from, you know, schools and stuff like that. But I'll show you more. Now, what Martin's talking about is, if you can see me here, even steeper in some cases. But this isothermic would be anything pointing to the right here is really kind of considered an inversion. Now they get deeper inversions, right? More of an inhibition of rising air, right? Because it's the more it's to the right, the more it's leaning to the right, the less air you're going to need more for air to escape that. So that's where we get like early morning fogs and things like that. And I'll show you that.
That's winter in Denver.
Is it winter in Denver?
Yeah. If you've ever lived there, it's interesting.
Is it just foggy all the time?
It's not a fog, it's pollution, especially in the winter. Denver's in a bowl, and when it gets inverted like that, it becomes a perfectly stable line. And you could actually have your airplane down in the pollution and your head above it. It's
yeah,
so
I'll give you, so Martin, kind of to add what Martin's comment was, if I saw a profile like this, let's say the temperature was rising like this, unstable. This is actually a pretty common thing. You'll see temperature rising like this, changes quite significantly, and then you have this mild inversion. When you cross that line, you can actually see it. You can see that line of haze as you're going through there, and then it becomes very stable and nice and smooth after that. So this is something that I typically look for, is I look for where does that change. So that determines what altitude I'm going to cruise at with my family. And we'll have some examples here to show you what that looks like. All right, so the other important piece to understand here is what saturation is. And we probably all know, but when temperature and dew point are the same, you know, we're going to have clouds. And if it's very deep, meaning it goes through a long distance of altitude, this would indicate rain right here. Any kind of like a long, deep saturation would be rain. This is a large temperature dew point depression and makes for a very dry day. This would be like an ideal day, right? Straight up and down temperature and a wide depression. All right, so let's look at some of the signatures. Actually, are there any questions? All right.
We're getting to the good part right now.
All right, so we're going to look at some of the classic signatures. On all of these, to make it kind of easier, I've put this blue line on the zero isotherm, so everybody knows where the freezing is. And always to the right is going to be temperature, so following this line here. To the left is our dew point. And then this is actually the lifted parcel. This is the analysis line. So it just kind of gives you an idea. Now, in some of these examples, I pulled these off of a site that covers Skew-T. What they didn't do is, we're looking primarily at what this looks like, not where it's positioned on this on the actual Skew-T. Does that make sense? So some of these would, for the type of weather, they would have to be positioned either to the right or to the left. But again, we're looking at the signatures, what they kind of look like here. On a dry day, what we're looking for is a wide spread between temperature and dew point. That makes sense? And primarily, and you're going to see, this is primarily where we fly, kind of in this area here. This is probably the 10,000 foot mark, somewhere around there. Oops, my bad. I don't know if you guys fly any higher than that. Those of you who are lucky enough to have turbo or maybe a turboprop or something like that, you're often able to just fly above much of the weather that I'm even going to talk about. All right, so let's look at what we'd say the classic inverted V. So what we mean by that is here's the temperature, again, kind of unstable air, and here's the dew point. And then they meet up here. Now, when there's about a 3 to 4 degree difference, you're gonna see like broken to scattered generally. If it's any wider than that, it'd probably just be scattered. And then a 1 to 2 point, you're gonna see broken. And of course, 1, it could be just a solid layer. Again, this is all predictive. So it's kind of like, it just gives you a general idea of what you might expect to see while you're flying. So what is important about this? There's a couple things. Oops. I keep trying to move. Oh, bear with me for a second, guys. I have a bar as a presenter that's kind of getting in my way. All right, so what we have here is a potential one, it's gonna be very turbulent for you to fly up through this. So where this starts, this is probably a high altitude airport somewhere because the surface is depicted here, or a high altitude plot.
It's Albuquerque.
Oh, yeah, you picked that up. What's the altitude of Albuquerque?
If I remember right, it's between 5,000 and 7,000, depending on which part of the city you're in.
That's why I love these interactive presentations. So this is Albuquerque. I don't know if I mentioned that earlier. So what we're seeing here is that where the temperature dew point are getting close up a little bit higher up here, and any kind of convective activity would be mainly occurring back up here. But what we're really seeing is the potential for high winds, because you have warm air, very warm air down here, and much colder air up here. Any air up here could be, once it comes down here, it rushes down through the atmosphere, causing high winds. And then there is, depending upon the cape and things like that, this one actually has a cape of 0. I'll explain what that is later. Convective available potential energy. You could have high convective activity, or we also could see microburst due to air rushing down, condensation, all those types of factors kind of combining for a microburst scenario. So again, something you would want to look for. This wouldn't be a great day to fly, honestly. It might be okay if you can get up above, but you're looking at pretty high altitudes in this type of plot. All right. Next one, this is like one of my favorite days to fly right here. Even though there is a cape of 2,000, which means there is a potential for thunderstorm.
Miami, it's always beautiful.
Well, not always. I've definitely flown on a couple days where I was like, that was a mistake. But what we have here is, we have a small temperature dew point depression for a long, from large amount of altitude change. And we're simply going to see rain here. Now the ceiling, because I can tell you the ceiling is going to be probably somewhere around here, whatever altitude that ends up being. So it might be a relatively high ceiling and then lots of rain, but smooth flying really, because the temperature is pretty much straight up and down. Again, because we do have a cape, a positive cape, we want to kind of keep our eye out just in case. All right, here's another one that looks much like the inverted V, but it's a whole series of them. And on these type of plots, this signature, if you have a high like this, we have a low cape. But if we had a plot like this one with the cape positive, a lot of area here. So if this line were over here, this could be a very high potential for something like tornadoes, microbursts, definitely for high winds. So there's a huge potential there for very bad weather with this type of plot. All right, snow and ice. As everybody knows, pretty much the hot spot, if you will, for ice is basically 0 to -15 degrees Celsius. When we get any colder than that, typically it is something that wouldn't collect on the airframe, and also it just doesn't like to form there. Now, very high altitude clouds themselves are all ice crystals, just because it's extremely dang cold up there. But what we see here is we have the freezing line, and all of this is freezing from the ground up. And then we have this, these are very close, and then it is close here. So we may have a pretty significant amount of snow or potentially ice. It just depends. You get icing potential when it's a little bit closer to freezing 0-degree line. I'm just checking the time here. All right, the next one is freezing rain or sleet. And what we're seeing here for a pattern is we see temperature and dew point together, and it's all freezing, and then it momentarily goes down in a warmer bit of air at this altitude. So it dips below freezing, melts, and then refreezes as it comes back over. So this is like, do not fly on this day. This would be a bad day to go flying. Just snow and ice potential in general, just stay away from it, obviously, unless you're well equipped for it. But that's what we're looking for is temperature dew point together, below freezing, dips down into warmer air, and then goes right back into freezing again. And then rain, what did I have here? Oops, sorry guys. So freezing rain or cold rain, basically it comes down, it's frozen here and then starts melting as it comes down through past into the warmer air. So it's going to be very cold rain / freezing rain, somewhere around there. Again, it's all predictive, so. All right, so this is that massive inversion that we were talking about earlier. Typically what we'd see like in the morning, where we have morning fog, where the surface is starting to warm up. And so the temperature from the surface to a very short distance rises quite significantly. And then it goes up to normal. So these are those days where we're stuck, even pilots with instrument ratings are stuck down waiting for something to clear out because it's simply just too low for us to get over. And sometimes the fog is only 500 feet thick and we just can't get through it. And this is a very classic thing to look for with the fold over. Questions, comments? All right, low level wind shear. This is an interesting plot. I'll get into cape and convective inhibition. And gosh, am I using the right word, guys? We'll see. We'll see in the next slides. So what we're looking for here is changes in direction in wind speed. And this one would be super bad. We have 45 knots, and then right below that at the surface, very little wind and from a different direction. So this could be a very dangerous situation. So you want to look for that especially in these lower altitudes near where we'd be taking off or landing. A lot of times you will see significant wind changes, sometimes 180 degrees. And actually, I think, Martin, you commented on a Skew-T I posted and identified, right, that there was a wind shear. It was a mild wind shear because the wind speed wasn't really high, but you'll see those pretty common up in the higher altitudes as well.
Yeah, that's right. I even recall seeing the kind of signature that you highlighted here with the circle pretty often. Usually I see it with, less of a dramatic speed change. So maybe a 20 knot shift. I see that quite often. And that usually doesn't worry me much. 45 knots. Yeah, I agree. That would be a reason to pause.
Yeah, that'd be a pretty scary day, honestly.
In the Front Range of Colorado, it's very common in the winter.
Oh, really? Okay.
Very common.
So it sounds like you've flown out there quite a bit. Is that something that you really kept an eye out for when you were in the wintertime?
Yeah, especially at 12,000 feet, because that's what blows across the Front Range.
Yeah.
So if you had some massive winds like that, it was going to be extremely turbulent.
Yeah. This one, I worry about crashing. Just so low to the ground.
Yeah, you'd be surprised. I had to learn, I did ADFs in that, looking just like that.
I'll be honest, I don't think I'd fly if I saw that. All right, so all those plots are relatively simple, right? Temperature dew point, how the temperature changes with altitude, and you gave us those kind of classic signatures. But it gets a little bit more interesting with the potential for thunderstorms and really convective activity in the summer. I think it is. It's more interesting to me. So what we have here, you guys cannot see what I'm dealing with, but I have a bar in front of me that I cannot seem to move, and it's blocking everything. Oh, there we go. I can't see any of your faces now. So, all right. So as with looking at the basic parts of the diagram itself, we need to talk about some of the definitions when it comes to looking at convective activity. So we have hopefully you guys can remember all these. I will give you a quiz later, but there's the lifted condensation level. So that's the pressure level, or essentially altitude, that an air parcel would need to be raised dry adiabatically, right, unsaturated, for it to become saturated. So what level would it become saturated? And all of these, when you talk about air parcels, so there's as part of Skew-Ts, there's parcel theory, kind of as part of this whole thing. So essentially take a chunk of air that all has the same quality, has the same temperature, has the same saturation, all those kinds of things. So as we lift an air parcel through the analysis here, that's what we're essentially talking about. We're lifting this parcel of air up through the atmosphere, and then we see kind of what happens as we lift it. We have the level of free convection, which is the level at which an air parcel would need to be raised so that its temperature is equal to the environmental temperature. So that is the kind of the point where the air temperature is such that the parcel would, so the air is getting colder from that point forward, and the air is warmer, which means it's going to rise and rise quickly. So that's the level of free convection. Now, where the lines come back around, I'm going to show you a graphic, by the way, so all of this kind of makes a little bit more sense. But we have the equilibrium level. It only exists if there's a level of free convection. So many of the plots that I showed you didn't actually have any level of free convection because it just didn't. That atmospheric condition didn't allow for it. But essentially, this is where the moist adiabat, denoting the parcel's path through the atmosphere, crosses back through the environmental temperature. So then they become equal again, right? And essentially, that's a point of stability. That is where, essentially, if you look at a towering cumulonimbus, a thunderstorm, where it caps off is typically where you'll see the equilibrium level. Hopefully that makes sense. The cloud will no longer continue to rise and grow at that point. The lifted index is the temperature difference between the environmental and parcel temperatures, typically taken at the 500 millibar level. There's other kind of points for analysis that are similar to the lifted index, just taken at different levels. But a lifted index will give you an indication of potential thunderstorm activity, or if the conditions are kind of ripe for a thunderstorm. And then we have convective inhibition, which I was correct, even though it sounded really weird to say. This is the negative buoyancy force of the air. So it's really kind of what the parcel itself would have to overcome in order for it to reach the level of free convection and just continue to rise and rise and rise until it reached the equilibrium level. And then the big thing that we all kind of want to pay attention to is the convective available potential energy. So the nice thing is you won't have to do any of these plots, but it is nice to know where this information comes from. CAPE is essentially the positive buoyancy force. It's generated by the area from the environmental temperature to how the parcel would rise. And the larger the number, the greater the potential and energy that exists. If the level of free convection is closer to the Earth, it won't require as much mechanical lifting for that parcel of air to get into the level of free convection. So you'll notice that too with a lot of the plots where there's a high CAPE and there are thunderstorms, you'll see that the level of free convection is fairly low. All right, so I wanted to kind of refresh you on the basic components. So again, the isobars, right? That is the pressures, the dry adiabatic lapse rate, right? The moist adiabatic lapse rate, the isotherm, and then the mixing ratio, typically just called mixing ratio versus saturation mixing ratio. All right, so the lifted condensation level. Remember we talked about at what altitude a parcel of air would need to be lifted to be considered saturated. So when we look at these plots, we start at ground level where the parcel of air is, and we follow the dry adiabatic lapse rate until then we take from the dew point and follow the mixing ratio line. You just parallel it. Same thing for lifting the parcel. Where those join is the lifted condensation level. If we actually continued this line, the mixing ratio up, all the way to here where it touches the temperature line, that's the convective condensation level. That's typically where you would see the bottom of a cloud or the ceiling. I just didn't put that plot on here. All right. Now what we want to do is determine the level of free convection. So at that point, we are now going to follow the moist adiabatic lapse rate. You can see here a line. We're just going to parallel it up until it intersects with the temperature line. So this is the altitude at which we would have free convection if the parcel of air were lifted above this. This area here is the convective inhibition. It's what's preventing the parcel from being lifted, right? Because the air is warmer. All right, then I'm going to expand the plot here. So we have the level of free convection from our last drawing, and then we continue to follow the moist adiabatic lapse rate. Again, just kind of parallel the lines. And then where we cross back over the environmental temperature is the equilibrium level. Again, this is very high, and as you know, large thunderstorms cap out actually quite high in altitude. And if you see here, actually, my next slide shows it. So the convective inhibition, or the negative buoyancy area, and we have the positive buoyancy area. So air tends to sink here and rise here, based on the temperature from where we took the parcel of air. So again, we're taking our sample at the surface at that temperature. You can actually plot these in different temperatures, but that's not really useful to us as pilots. So is this making sense, guys? I think everybody has fallen
I
asleep.
don't think you can, I don't think, you said you can't see us, but I think everybody's kind of nodding their heads.
Okay, yeah, I cannot see anybody. So just FYI on that.
It's always fun to present to a screen by yourself, right?
Yeah.
You're doing great. Thank you.
All right. I
But
know
this
it's
is
a lot.
starting in the lower flight levels, right? That's where you're getting the lifting.
So right now we're manually, if you will, I'm holding this parcel of air in my hand and I'm growing taller and taller and lifting it up through the atmosphere. This is how it would react if I were to lift it through the atmosphere. Does that make sense?
Yep.
So how does air get lifted? I talked to, mainly in this situation would be like a mechanical lifting force, something that the wind is blowing and it hits a mountain and drives the air mass up, and then it could exceed the level of free convection and then go into, it would just simply continue to rise, and then we would have, you know, a thunderstorm or storms build. All right, so I've been talking about CAPE, convective available potential energy. On that app that I use, the SkewTLog Pro, you can set up what you want to see as far as data. You look on the right here, there's a ton of stuff I didn't talk about. But we have, this is the pressure in millibars at the level of free convection, lifted condensation level. The CAPE, look at this one, 4,385. I mean, that is a massive potential for, I mean, it's just ready. And look how low. So the negative buoyancy area down here, the convective inhibition is extremely small. It just, the air mass just needs to get a little bit off the earth and then it's gonna go crazy. But these guidelines on the left are really kind of generally good guidelines to use. 1 to 1,500 is just generally a positive CAPE, a slim, slight chance essentially of a thunderstorm or thunderstorm activity. 1,500 to 2,500, a very good chance of thunderstorms, and anything over 2,500. There, you know, you're gonna probably almost definitely see thunderstorm activity in the area. So that's a good number to pay attention to. And when you're looking at like the SkewTLog Pro app, it's just very easy. So when you're analyzing, you want to look at the CAPE. You can look at the lifted index. So this is a negative number. That's the difference at 500. I don't see the 500 millibar, but basically it's the difference in temperature between this point and this point, assuming that this were the 500 millibar. Does that make sense? That's where the lifted index, and that's a pretty high number. Anytime it's negative is what we're looking for. So negative 7.8, high potential. And so it identifies the stability. So here's the lifted index, 0 or greater, stable, -1 to 4, 5 to 7, 8 to 10, 11. So looking at 7 to 8, I mean, that's pretty large, almost extreme instability.
They need to do one ludicrous.
Yeah, ludicrous. That's pretty much, I should have made it ludicrous. Damn it. I'm going to change my slides. Thank you for that suggestion. I had an opportunity to be funny and I didn't take it. All right. So that is kind of the thunderstorms, the convective activity that we want to be looking for. And what I've done here is I'm taking my SkewTLog Pro app and I just took snapshots. I picked places to just kind of see what weather was like, what the prediction was for Skew-T, and essentially took the same time, went to that airport. Well, the one thing I didn't mention, if I put in Culpeper as my location for the Skew-T, what's going to happen is it's going to pick a point in that 40-kilometer grid. So as an example, if the nearest point is actually over the mountains or on the mountain, the plot may not be very accurate, right? Because we're going to see, if you're at 4,000 feet altitude versus 300 feet at Culpeper, you can see vastly different weather. So that's something to keep in mind as you're looking at airports, because you're not actually picking the airport. You're just picking a point geographically, and then the system goes out and finds the nearest point on the OP40 grid to pull the data from. So I just want to make sure that everybody knows. But right here, we have a nice, clear, dry day. I mean, look at this huge depression in temperature dew point. This is like a beautiful day. and this is Culpeper. And I just pulled the weather at the same point in time. And you can see very light winds. It's just a beautiful, gorgeous day. Definitely one you want to fly on. All right. Then I'm looking at different layers. We talked about this in some of the other plots. And again, looking at those other example plots and signatures, they get a bit complicated, right? There's just a lot going on. I think this app has done a really good job. By the way, I have no affiliation whatsoever with the app. I just like using it, so throw that out there. It does really nice things, like it highlights the 0 degree isotherm, and you can see it's blue on this side, so it's obviously colder, warmer on this side, but it makes it very easy to look at. So here we have a 3, 4 temperature point difference. So we're going to probably see like broken, scattered, and that's exactly what's reflected here. A lot of times sometimes you won't see reporting up at these kind of altitudes, but we have scattered 1700, and you can see it's a little bit closer here, the temperature and dew point. So I'd say this was pretty darn accurate. And again, this is, even though I pulled it at that time, it's still considered a forecast. And I think it is pretty darn accurate. And if we look on the upper right here, I asked in my settings on the app to see CAPE, convective inhibition, lifted index, lifted condensation level, level of free convection. I see a CAPE of 0. There's pretty much 0 chance or probability of any thunderstorms here, right? And also, if we notice down at the ground, we see the temperature slightly getting colder with altitude, more than the standard change. But, more than likely we see light winds. It's probably going to be just maybe a couple little burbles at most, and then it gets very stable up in here. And just a wonderful flying day. But I know also by looking at this, if I were a VFR only pilot, I don't know, it is scattered 1700, but I want to look at maybe future to see what it's going to look like in 5 hours. So the nice thing about this app too is you can push forward in time and it'll give you the next prediction, and you can kind of go up. I believe this goes out to 18 hours. So it gives you the ability to say, like, it may look wonderful now, but what does it look like? What's it going to look like in 4 hours? And I may see this might go to broken, and that creates a problem for me as a VFR pilot, right? All right, so haze, remember that fold over? So haze or fog, there's that classic fold over from the ground. And let's see, where did I pull this from? Missoula or something? I don't know where MZZ is. But essentially, very thin layer here of haze. And it might be fine for a VFR pilot. I don't know what it's showing haze clear below 12,000 IFR. When you get out there, maybe in an hour, something like this would clear up. And for a VFR pilot, not a big deal, especially as the day, things maybe, now this is at night, but I'm just saying if this were in the morning, chances are it's going to warm up and then this will just go away.
I like the density altitude on that.
What's that? Yeah, negative.
Negative.
Yeah, that's nice. All right, and then we have a cloud. So we have this long temperature dew point. It's together all the way up until, doesn't even split out to like 16,000 feet. So, this is a rainy day. How much rain, it depends on total moisture in there and all that kind of stuff. But my guess is a day like this, I would expect heavy rain at points as well. And I also have it set the parcel plot for me. I never used to do it, but the geek in me wants to see it. All right. So here's the video of kind of what I do on my iPhone. So I want to find out, obviously I know where I'm going. I want to see how long it's going to take me to get there. And I just use ForeFlight to help me out with that. And I pick an altitude. Typically, if on longer trips, I like to fly 8,000 to 10,000 feet. That's where my airplane is pretty happy.
Try 10 to 12. It'll like it even more.
Well, yeah. When I went out to Denver, I was up at 12. Also depends on what kind of terrain I have. Like if I'm going out to Denver and the ground level is 5,000 feet, then 12,000 sounds pretty darn good to me. All right, so then I open the app. I know it's going to take me, I believe, roughly 3 hours or so on this flight. And then I have this slider here. I can choose what the interval and the plots are. So I'm plotting every 40 miles. Sometimes it takes a little while because it's loading multiple plots. So here, actually, I want to see if I can pause this. So things again, when we are looking at analyzing the Skew-T, I want to be looking at the wind bars on the right. One, what direction they're coming from. So I can see, they're actually not that bad in intensity. Sometimes when we fly west, we're looking at, significantly higher winds. And it really doesn't change all that much as we climb up. So it's really not that bad. But again, I'm looking for like wind shear, those types of things here, and how the intensity of the wind changes. And then the temperature and dew point. So here, temperature and dew point are pretty well spread. I wouldn't really expect too much. Pretty clear, right? And as we progress, you're going to see the temperature and dew point start getting closer. And then I have multiple layers now. So keep in mind where I was at. Ah, shoot. Sorry, guys. Let me get back to that again. The problem is I have a control here, slide control that is right over my video control. See if it's here. Ah. That's why we have an hour and 45. All right, there we go. So now, what are we starting to see? What do you guys see? I want you to analyze this for me. I was planning on flying at 8,000 feet, right?
See a thick cloud layer right at the freezing line.
Yeah, and it keeps going up and up, right, for several thousand feet. So there's a lot of moisture there. So what I'm looking at here is an icing potential at 8,000 feet. And I would say probably a severe one. What I didn't capture on ForeFlight was there was actually an icing air mat for this. So then get this thing to start back up again. Dang it. All right, so let's let it continue to play here. All right, lots, let's see. So then it opens up a little bit, get closer, then we get back to temperature dew point together in the freezing level. And then when I get all the way there, look at that. I might, it's like I don't know if we'd see any cold rain. It'd probably melt by the time it gets down there, but it's, low clouds. It's going to be rainy and crappy. No fun.
But that's saying fly low.
So essentially what that told me, what did I do here? Oh, I picked up the weather, I think. So there's kind of the, 9,000, and I'm looking at the different times. So broken 5,000, how accurate the TAF is, I don't know. Light rain showers, overcast 3,500. So, but by looking at that, I decide if I were taking a trip, I definitely wouldn't want to be just sitting at 8,000 feet where there's a potential for ice. I'd probably try and fly a little bit lower. It would impact my decision making for sure. So, as far as using it for planning purposes, using that mode where you can plot along your path is extremely useful.
So Rich, did you do that whenever you went into Manio, 2 weeks ago? I'm sure you did, but I'm curious to kind of know like what you learned from that. via ForeFlight and all that stuff. Like, did you see it before you even got into it and it was exactly on spot as far as what you expected?
I did pull up a plot. From here to Manio really isn't that long of a flight over that large of a distance, but the major change occurred, and you well know this because you flew on the same day. It was extremely windy along the shoreline. So, looking there, what I want to see on those kind of days is like, is there a low level wind shear issue? Am I seeing large directional changes in wind? That kind of stuff. That day was actually kind of a pleasant day to fly. Yes, the additional information was, I knew the cloud layer and where the air became stable, and I flew there. And then once I climbed up above like 5 or 6,000 feet, I can't remember exactly, it was just smooth as butter. It was like super smooth ride all the way down there. And I have my mother-in-law who is extremely sensitive to every little bump. She thinks the wings are going to come off. So I'm sure we all have passengers like that, but I want to make sure everything was nice and smooth for her. Now I did warn her, like, as I descend down through this, it's going to get bumpy.
Right.
And so it gives you so much information. I knew exactly what to expect on the trip. I knew what the winds are going to be like.
How long did it take you to get comfortable with reading these charts?
I think that, and Martin may agree with me here, but so let me zoom so I can see everybody.
Yeah, if you just stop sharing, you'll be able to see everybody again.
Well, this is going to be available to everybody. So there's this UCAR training. I mean, this is like legit weatherman training stuff if you guys want to go really in depth on this, but we'll make these slides available to everybody. You guys can peruse them, but really it's all about practice. And at first, it took me a lot more time to do the analysis, looking at it and really understand what I'm looking at. But the more you look at it, the more it kind of just makes sense. And you're going to see those signatures come up, and you're going to recognize the signatures, and you'll say, oh, well, I should probably look for turbulence, or I should look for ice, or I should look for this, or potential for, what highly unstable atmosphere. Do I even want to be flying today? And those things kind of tend to pop out at you. But, Martin, I'd love to hear your comments if you're still on board.
I think he may have jumped off unless I don't.
Okay. Yeah, he's a good resource. Obviously, we all know he's a pretty bright guy with a lot of experience that we could all draw from. But yeah, I mean, it's just a matter of, I've been using them regularly for about 3 years. And I think I'm okay. I think I'm pretty okay at them. Definitely have room to grow. But as far as I'm concerned, one of the most invaluable tools that we have, combine that with, all of our other aviation weather products, and you're going to have a really good idea what you get yourself into.
Mm-hmm.
Hey, Rich, it's a $15 app. Is that just a one-time hit, or?
Yeah, it's one time. It's worth every penny, I guarantee you.
Yeah, it's not a high cost.
No. I mean, you can navigate on your phone to, rucksoundings.noaa.gov and try and run your plots. But, it'd be great if that were integrated into ForeFlight, actually.
Well, it was in WeatherSport, but it got taken out for some reason.
Yeah, I imagine that we'll probably see something like that in the future because there are just more pilots using this for obvious reasons.
Well, the WeatherSport is amazing. Who here uses WeatherSport?
I do, Jackson.
I do, and thanks, Gabe.
But it was in there. John, I think John might have known why. I don't know. I heard it got removed for some reason. I assumed it was selling government data or something like that. But it used to be in it used to be in WeatherSport.
Yeah.
Interesting. I mean, SkewTLog Pro gets away with it. I mean, I don't know.
That's what I was wondering.
It could be potentially how it's presented, which gets past any kind of restrictions. I don't know.
On WeatherSport, when you select the SkewTLogP, it takes you to the rucksounding.noaa or noaa.gov website.
Yep.
So I had a question for you.
It used to do it directly, and I think I'm meaning to talk to WeatherSport guy about this. He could release a free version of WeatherSport with only Skew-T in it, and then also incorporate into his paid product, that would get around that problem that he had, that copyright problem or whatever he was experiencing.
So I was trying to follow along, Rich, while you were talking, and I pulled up the Skew-T chart for Leesburg, my home airport. I saw the blue curve for dew point. I saw the red for temperature. Then there was a pink curve. What is that?
It may be the analysis line, but I'm not seeing what you're seeing, so I can't really definitively answer that question.
You can go ahead and try to share if you want to, if you have it up.
Let me pull it up. Well, I have it on my iPad.
Oh, okay, yeah.
Hold it up to your camera. Yeah, I mean, you guys are welcome to. Here's the other thing. I really enjoy this. If you want to, I'm sure Martin's open to it as well. Just post something up like on the group and say, hey, here's an interesting plot. What do you guys think about it? Might be cool practice for everybody as well to kind of take a look at it and see what they catch. And that's kind of what I was getting at the day that I posted that plot. Was just kind of get people looking at it and thinking, and trying to identify potential dangers or things like that.
So how does this compare to like the GFA tool on aviation weather? Have you ever compared the two to see if they match up?
Well, I mean, the data, to my knowledge, all the data for this comes from NOAA. I don't think people are out there running their own supercomputers and crunching the numbers to provide the data. I think it all sources from there. If to answer your question though, I haven't done it, but I believe this. If it's the same kind of plot, it's more than likely from the same source.
I think that was really an ironic question from Mike, who is also known as Scotty right now. That doesn't match up. I mean, Mike, you're going.
There's a story behind that.
Okay.
In another Zoom meeting, we go in and change our names based off what's being discussed in the meeting. And apparently that was what was there last. So that's how it came up.
Sorry, I just had to. I had to go there.
It was Star Trek related.
So I'm interested. I mean, do you guys feel I tried to make it detailed enough to be able to give you the ability to do the analysis and understand where it's coming from, but not make it too crazy?
I thought you did great.
Was it good for you guys? Was it consumable, really, is kind of what I'm getting at for us pilots.
You showed where the fog was, where the rain was, where the convective activity, and where freezing would be. Those would be the things that I would be interested in. So,
yep.
Okay. Well, great. I'm glad hopefully it was helpful for everybody. And then, like I said, just continue to practice with it. And anybody's welcome to reach out to me. I definitely am not a weather expert, but I do know some. So if I don't know the answer, I'm sure we can find it.
Yeah, that is awesome. Rich, thank you so much for doing this. And what a amazing concept to be able to study. I mean, and the fact that you have like such a deep knowledge within all of this is pretty cool. So thank you for taking the time. Anybody have any other questions for Rich? Cool. I see that Gary Shiflett was on, and Gary, I'm surprised that that you mentioned that you guys were using this. What's the difference or the similarities, or what is it that you picked up tonight, just out of curiosity?
You broke up there. What? I didn't hear the first part of your question.
You mentioned in the chat that you've been using this for a little while, or had used this in the past, I think.
So let me preface that by saying I was taught that in my initial training by my instructor, and it probably took me a good 2, 3, 4 years before I even really understood it. Let's just say my flight yesterday proves that I didn't actually use it, because as I was descending through the layers he was talking about, we could feel all those things he was talking about. But a little bit of planning would have prevented that. But there are definitely charts that I've seen and worked with and had to learn. And ForeFlight and some of the other apps do a good job of translating some of them. I think some of the charts he was showing that ForeFlight doesn't do at all, but I mean, it just shows you how complacent some of us get on technology and apps that, like even a METAR, they just plain language give you the METAR, and then you have to look at a METAR in general, and you're like, well, what does that remark mean? What does that mean? It just, aviation is changing with technology, and sometimes it's not always for the better, in my opinion. But
well, I think that, I mean, to your point,
it definitely, listening to you tonight and looking at the charts, and it brought back some nightmares, some good memories, but it definitely, when I was first learning, and my instructor, she fancied herself a bit of a weather expert as well, so she dove really hard into charts and weather, and I was lost 90% of the time, and it wasn't until after I was already rated and just sitting down and going through them that I even kind of understood them. But Rich, you did a good job tonight, and it brought all that back, and I remembered them. And my wife was a little upset on our flight yesterday. Her stomach got a little upset, so that could have helped us, because you could literally, when we were coming back from Tangier yesterday, we could literally see that inversion layer where the scattered layer was, and then as we came down through it, you could just feel it and see it. And a little bit of planning would have brought that, would have prevented us from having to spend more time in it. So
I think what you're trying to show, thanks, Gary. I appreciate it. I'm glad you're on board as well. Your expertise is greatly appreciated in the group.
So Rich, can you see the pink curve?
Can you move it up a little bit? Because I can't see where the base of it is. I don't know. Did you click on that point to create that line?
No, I didn't know anything. I just pulled it up.
That looks like the moist adiabatic lab for. I can't really see it that well, so I apologize. It's just getting more blurry.
There you go. Oh, yeah.
So all these acronyms like CAPE and CLIN and TT, KJ, I mean, there's no legend to explain what this stuff is.
Well, you know, Google, but in my slide deck, I do talk about CAPE is the #1 thing you want to look at. It's convective available potential energy. That's the big one, really. If you're looking for the potential for thunderstorm activity or you know, bad convective activity, that's the number you want to be looking at. And in the slide deck, there's some guidelines, like 1 to 1500 is kind of like a mild positive CAPE. 1500 to 2500 is like a, you know, higher risk intermediary, and then anything above that is a very high risk of large convective activity. But again, you know, there's the potential activity. There's the CAPE, which is the potential, and we talked about that. That's the positive side. But if you also have to look at the negative, if the negative or the convective inhibition is all the way up to like 3,000 feet, then it's unlikely that you are going to see a thunderstorm at that point, unless something mechanically lifts the air. Does that make sense? To get it in there to the level of free convection and beyond. So, but yeah, just I'll make sure. Actually, I think you still have the link, Gabe. You can just share it with the group. I'll make it public.
Yeah, absolutely.
And you guys can just download it and have it for reference. And a lot of I do have notes in there, and a lot of the notes I took from sites, which had, like, especially on the signatures. So there's some stuff in there that may be a little bit beyond our conversation, but you kind of get the general idea.
Yeah, what I'll do is I'll take tonight's recording. I'm going to put it onto our YouTube page and then throw it into the website. And then I'll put it on Facebook for those that couldn't see it. But Rich, I really do want to thank you for taking the time, the expertise, and sharing with us the knowledge that you have around this. So everyone, a virtual round of applause for Rich.
Here.
And thank you so much. I'm going to hang out for a little bit. If anybody wants to hang around a little bit. Rich, I know you got to go.
Yeah, I got to go. I got a hockey game.
Yep, absolutely. But, I'll be on for a little bit. So if anybody wants to hang and talk about a few of those apps, because I actually do have some some thoughts on those. But Rich, thank you. Have a good night.
Thanks, you too.
Thanks, Rich.
And,
That was good.
See you.
Thanks, Rich.
See you, Rich.
So I have a question, Gabe. You mentioned Weather Spork.
Yep.
I did download the app. I have it free for 14 days. Is it good? Like, how would I use it differently from aviationweather.gov or any of the other NOAA sites?
Well, so for me, I mean, I use about 3 or 4-ish different apps to give me the sense of what I'm looking at. With WeatherSpork, what I like is that you can see the ceiling and then the tops, and you can kind of see that along your route. And it's laid out by the time in which you want to leave or depart. And I really like that. I thought it was, for my last trip, it was literally spot on each time, there and back. It was perfect. I've used it before. But for me, it was, wow. Winds were great. Ceilings were great. It was literally spot on. And I know Vic just used it as well.
Yeah, it was fantastic. It was a super bad day in terms of winds, and that app showed literally what you would experience all the way to Cape May, and you could anticipate it every step of the way. So I thought that was like fantastic.
What app was that?
It's called WeatherSpork.
WeatherSpork.
Spork, like a spork. But what I will tell you is that what I was looking at was, where we're leaving from, the destination, and then I was changing the time in which we were leaving. And every single time, like when I first looked at the weather, probably on Wednesday, I was like, oh my gosh, we're not going to be able to leave until like probably Tuesday or Wednesday, like another week. Well, as the forecast changed, WeatherSpork was updating all that stuff. And then all of a sudden you started seeing the ceilings lift, the winds come down a little bit, and then you knew where that was on where you're leaving and where you're going. And it literally was, I'm not kidding, like it was spot on. And I was like, this is amazing. That's not the first time that happened. So I'm a big fan. And John Somiak actually spoke about this particular app probably a year ago to the group in person. So I would definitely try it out on the, Gary, you can't see it because you got your virtual, but I would try it out for the at least the free trial for sure.
The advanced paid version has like 100-day forecast.
Mm-hmm.
Not that you would use it all the way out there, but if you're doing any kind of forward planning, it's actually very good.
So like whenever you guys plan, or anybody that's on the call that plans, do you have just like a few apps that you go to, or is it one? Like what is it?
Is it that one?
Yep, that's it. Yep.
All right.
So what do you use for your planning? I mean, other than, aviationweather.gov or anything like that, anything else that you guys use that you kind of piece together?
Windy is the other one.
Yeah.
You use that as well, right, Gabe?
Yeah, for me, it's Windy, ForeFlight, and WeatherSpork, and all
Yeah,
three
that's
of those are basically
mine.
my go-to. And that's about it. But
so I used to use Weather Underground because you can plot the temperature and the dew points, and that kind of like the Skew-T lets you see when there's going to be like clouds, but you can't tell what the altitude is.
Mm-hmm.
So it's like, oh, I'm going to ditch that for maybe the Skew-Ts.
Mm-hmm.
Yeah. Yeah, the Skew-Ts are great. I would love to honestly really dive into that. I just have never done that just because apps and technology are very easy to do. But Rich clearly knows his stuff on those. That's pretty cool.
I like at this time of the year with the freezing levels, it really does bring out, like if you looked at, our airport, Leesburg today, right. It shows it at like 10,000 freezing level and cloud layer because, the merging of the lines are there. So if you're flying anywhere at those altitudes, that's I don't have to worry, obviously, but anybody who does, it's pretty good to know.
Mm-hmm. Yeah, I mean,
is that windy?
No, that was Skew-T. I actually bought Skew-T while we were talking.
Yeah, but Windy, I believe it's a red app. It's the second one that you've got there. Yep. That's also super cool. And it's kind of crazy to look at what the differences are between windy, weather sport or even ForeFlight in those areas. And then you have to figure out like, what's the middle? Like, where are these things at? Because they are a little bit different. And that's, I think, where you can then start to paint this picture for what it is that you're about to either go through or be in. That's the reason I use those three. I mean, I think that they're spot on. I mean, relatively speaking, I mean, you're going to find where they're at, but all that information you kind of interpolate and you're good to go.
A friend of mine that works for National Weather Service, I was discussing windy with him. He was not familiar, but it includes the European models, which I always thought they were crap for hurricanes, but he said they're actually the best models that they like to use. And he was absolutely shocked that pilots could access European models without paying for them via windy.
So the funny thing is that the European models, when I used to live in Florida, is that that's what we actually followed for the hurricane track. That was it. I mean, we would follow those all the time. Those European models are pretty spot on for whatever reason. But yeah, getting that information for free is pretty crazy when you think about it.
This is good stuff, Gabe. I mean,
Yeah,
it's
the thing about weather is I mean, there's so many, Mike Schwartz. I mean, the weather stuff is like nonstop, but I feel like what you've got to do is figure out a way to kind of get your go-tos, and then literally piece them together, puzzle them together to be confident in what it is that you think is about to happen, or what you're going to be in. And I don't know, Mike, are you still on? What do you think about that?
My go-to and people that have flown with me out here for the last 10 years at least know that my go-to has always been experimental ADDS, aviation weather. And I've been using the HIMS tool since before it was an approved tool. It was always experimental when I got into it. And it's always been spot on because you can zoom out and see what's going on. You can look at ceilings and you can look at precipitation. You can look at winds on it, get your METARs, your TAFs, and you can zoom right into a very, very local area and see just exactly what's going on and get really accurate information with its ability to interpolate between reporting stations.
Yeah, again, I mean, I think once, so Mike, since you're there, I mean, what do you think about, people finding or pilots finding their own, go-to sort of things? And if they find that they're reliable, do you think that that's a good idea, or do you think that they should go somewhere else? Like, what do you think about that? Because I think that all of this information, we got to figure out how to, interpret, right? And how to put it together.
It depends on which hat I'm wearing. If I'm wearing an instructor or an FAA hat, I would probably say that if you want to protect your assets, go to an approved weather source where it logs the aircraft and the fact that you got the weather briefing. Because if something happens and you just went to the local news station and listen to Steve Caparizzo tell you what the 7-day outlook was and planned your flight accordingly, if something happened, insurance just may not cover you.
Sure. So whenever you go to ForeFlight and you're underneath your tail sign that you're actually filing for, and you press briefing, that's approved. That's approved, right? Okay. Just wanted to make sure that was clear. Because I do that every single time. Who else does that? When you go to ForeFlight and press briefing, I mean, everybody does that, right?
No, I call a briefer.
You call it briefer?
I don't use ForeFlight. I'm the guy that Steve Jobs said Apple wasn't for. He did. He said it was not for everybody, and I proved it wasn't for me. I couldn't get past the setup page.
Yep. I always call a briefer, then I can ask questions I want on topics that I'm worried about, like coming home from Lancaster 2 days ago, or yesterday, whatever day it was. I wanted to discuss the change in winds at evening, more so than just what the computer could provide.
That's good. By the way, I watched your flight plan home just because I'm a stalker, Ryan. But you know, the thing is too, whenever you think about it, it's like all of us have different ways of learning information or interpreting it. And for me, the visual aspect is super helpful. So that's why I like weather sport. I'm not even trying to promote it. I'm just saying that I think that visual aspect of, okay, I'm over Richmond, I'm going to have to descend if I'm flying VFR, and then come back up over, you know, from that, you know, on that verbal, you know, exchange, I might have a hard time understanding that. You know what I mean? So I think that it's all about how we learn. What do you guys think about that? Is that fair, or is that, what do you guys, you know, what's your thought on that?
So I use Garmin Pilot, not ForeFlight. And as you know, there's two schools of thought. It's like Android versus Apple, right? I love Garmin Pilot. I can file a flight plan through my Garmin Pilot, which I often do, but I find that if I go to 1-800-WX and use their flight plan, you get a ton of data, especially on weather and NOTAMs. I found that to be really useful. But this Skew-T stuff, I think, will give you those point data on cloud layers and temperatures and winds and stuff like that. So I'm really going to check this out.
Yeah, that's cool. Who else is going to check it out? Hey, by the way, Lucy, how are you? Oh, you're on mute.
Hi. I'm gonna.
I use
Trying to get you. There you go.
I think it changed entirely how I fly. I use ForeFlight. I think it's one of the best inventions this century.
And the thing about ForeFlight is that they're always updating it, right? And then it's also hard to keep up with their updates. I feel like it's like, wait a second, where'd that go? What's happening here? But with ForeFlight too, though, I also find that sometimes the TAF is so different from what you can find on like a website. That's the reason that I'm trying to say, like, you know, you use these things together, because if not, you're relying on one source of information, and then all of a sudden you get there and you're like, wait a second. But if you piece them all together, it works. But I too love ForeFlight.
But I also have the weather sport
for the tree.
So I also have that.
Yeah. There you go. There you go. Anybody else? What's anything on weather, on apps, on anything that we should know about as far as planning for weather? Other than Mike's perfect sunset in the background there. Or Scotty, I'm sorry, Scotty.
Yeah. So I've been a big fan of the GFA tool, because if you bring it up and you run through it, you got cloud layers, you got the freezing level, you got ice, an icing forecast, a convective forecast, whether it's marginal VFR or not. You can kind of scroll through it, and you can scroll through time, and it goes forward about 16 hours. So you can kind of, as you come into the day you're about to go fly, you can kind of scroll through it and see what the forecasts are going to do, and then compare it to the actual forecast with like the prog charts and everything else. So that's kind of what I've been using, and it's in the tools on aviationweather.gov. Now, Mike Schwartz brought up the HEMS tool. I haven't played with that, so I don't. Is that any different than what GFA is, or?
Actually, it is. It'll give you more of the information on a single screen, and it also allows you to actually zoom into street level if you really wanted to do that. So if we want to know what the Smokehouse farm looks like weather-wise and visibility, you can zoom in on that location. It would let you know exactly what the local weather is at that point.
So Gabe, when all those annoying air traffic controllers were making me wait to go into Dulles yesterday, I was trying to find your place and I could not find it. I was like all over the place.
Well, I heard so much traffic yesterday, and frankly today, I'm like, what in the world's going on? Because whenever you hear the engine, you're like, climbing out, and then all of a sudden it comes back, and then you hear it coming back around. You're like, what the hell? So you go back outside. You're like, who is that?
Well, I was listening to our frequencies and trying to figure out when the arrival bank was over, just based off of what I was hearing. And I did slow flight from Casanova all the way up north of Leesburg and then back to the Potomac intersection at 65 knots waiting. And I'm like, wait a minute, I could have been looking for Gabe this whole time. But at slow flight, it's a lot harder to do turns around a point. So.
Yeah. Well, just for reference, I mean, we're basically right at Jason. So if you put in Jason, we're just to the, I guess, south about a half a mile from Jason. So there's a lot of people that fly over, but I hear it all the time, and I'm on client calls. I'm like, wait a second.
So you're just south of Mount Weather.
Pretty much, yeah, yeah.
So you need to put some skylights in.
Oh, that's what I need, Gary. Yeah, that's what I need.
Yeah.
Lasers. No, I'm just kidding.
We can do that. I mean, it's just a couple of changes to your ceiling and your roof line. That's it.
Yeah, I know. You could do that for me.
Your office is on the second floor. We can do this.
Yeah.
So you're down by Upperville, not Leesburg?
We're actually between Percival and Middleburg, right in the middle. And so if you go out Snickersville, you can see Mount Weather, I think, pretty well. So if you look at Percival proper and then Middleburg, we're right in the middle of that. So
The trick is the GPS coordinates.
What's that?
GPS coordinates, and then really zoom in on it when you fly over, and you can't miss it.
Yeah. But anyways, so I didn't mean to get on this topic, guys. But no, this is awesome. I think that for all of us, I mean, for me, I know for sure, it's like always learning about weather and how to read it. And I think that this past flight for me was one of those flights where I'm like, man, I like the fact that we have technology. I don't want it to fail, but I also don't want to rely on just one thing. And I think that this Skew-T would be a nice enhancement to look at weather. So I hope that all of you do too. And I think that Rich did a great job. What do you guys think? Thumbs up. Oh, thanks, Zach, for the waypoint on that.
That's where I put it. That's where I marked my for flight, and it did appear to be over your house. So. Oh,
it is. Yeah, I know that waypoint. There's a helicopter over right now that doesn't seem to want to go away. But just so you know, the reason that there's a lot of helicopters is because Coon is about a mile away. So they're bringing their helicopters over all the time. So I look at helicopter traffic. I'm like, who is that? Is that Gary? Is that on a training flight, or what's going on? But, well, I know that everybody's probably got to jump, but I do want to remind you that we do have some meetings coming up on the 6th, the 8th, the 12th, and the 14th. The 6th and the 8th are pretty cool because this is going to be another Wings event with let's see, it's Thomas Turner, and I don't know if anybody knows him, but he's got a ton of courses out there. Chris helped line that one up, and then we also have obviously Mike, your event with IMC VMC. That's also with Wings credit, if I recall.
That's correct. And actually, I don't do the VMC. We have Chuck Kyle does VMC. Although we have been known to cover for each other, but yeah, so I do IMC and he does VMC. They both run an hour, and we do stick to the time schedule.
And let's see, so you're going 2 hours on that, right? And so how to sign up is through either the Wings email or the Facebook event that we've got, right?
Correct. And basically just pre-register for the Zoom meeting like you would for any other, because we use who's logged in on well, we use who's signed in for the Zoom, and then we also look at who comes into the Zoom meeting and how long they were in the Zoom meeting, because we go back over that to give the Wings credit. So
yep,
that's how we're doing it.
Yep, same thing that we've been doing as well. And you know, so the thing that is that needs to be said is that for those that see this video afterwards, is the reason that we have a registration for Wings events is the fact that we can actually track attendance, and I think that's really important. So that's the reason why. It's not that we're trying to make it difficult, but we really do have to do that from the FAA standpoint. So I just want to let everybody know that. So Mike, thank you for that, or Scotty, appreciate that. And then lastly, we do have 2 more events which are back to back with the same person, which is Rich Stowell, and that is on the 12th and the 14th. And the title of those events are still being developed, but I haven't put them on Facebook and or the website just yet, but they will be coming, and it's going to be pretty sweet. There's a lot of cool stuff that I think we'll learn from Rich. So with that said, I mean, I hope that everybody has a good night, and thank you all for joining. And Rich, when you see this again, thank you for giving us our presentation. But everybody, great to see all of you.
Yep.
Thanks for hosting, Gabe. Have a great evening.
Hey, you guys too. Take care. See ya.
Thanks, Gabe.
Bye.